Hi, everybody. It's Professor Mitchell, continuing with Chapter 5. In this video, we'll look at Section 5.3 on Venn diagrams and counting. To do that, we will look at the basic regions of a Venn diagram and how to use them to solve counting problems. Each Venn diagram divides the universal set into non-overlapping regions called basic regions. In this example, we will show the basic regions for the Venn diagram with 2 sets and with 3 sets. So the Venn diagram with 2 sets has 4 basic regions. You can see them numbered here. You don't have to number them in this order as long as you number all 4 of them. And then in the Venn diagram for 3 sets, there are 8 basic regions. And again, they can be numbered in any order. All right, so let's look at the example that we looked at in the last section. For the survey of the presidents of the 500 largest corporations in the US, where 310 had degrees of any sort in business, 238 had undergraduate degrees in business, and 184 had graduate degrees in business. First, we'll draw a Venn diagram and determine the number of elements in each basic region. And then we will determine the number of presidents having exactly 1 degree, graduate or undergraduate, in business. And to do this, I'm going to switch over to the tablet. All right, so I've jotted down the numbers that were given. So now I'm going to draw my Venn diagram. Okay, and just to stay consistent with the way the book did it, I am going to call these sets S and T. Normally, I like to name my sets after something. For example, in this problem, my first inclination would be to use U and G. The only potential problem with U is that U is usually used for the universal set, but we could think of something. All right, so 500 presidents, which is what all 4 regions need to add up to. And then it says 310 have some sort of degree. So let's number these regions. And I guess I'm numbering them the same way that I showed you a moment ago. Okay. So the first thing I see is that 310 have some sort of degree. So that would be the total of regions 1, 2, and 3. So there is something I can do with that right away. Since I know that regions 1, 2, and 3 have to add up to 310, that means that, oh gosh, I'm sorry. I forgot how I had numbered these. I meant to say 2, 3, and 4 here. So let me fix that real quick. Yeah, it's 2, 3, and 4. Okay. So now, since 2, 3, and 4 add up to 310, that must mean that region 1 is 500 minus 310, which is 190. All right, so there is one of the basic regions. Okay, so let's see what else we can do with this. 238 have an undergraduate degree, and I guess undergrad is S, graduate is T. All right, so if S is the undergraduate degrees, that means that regions 2 and 3 add up to 238, And we know that 2, 3, and 4 add up to 310. So that means that region 4 is the difference between 310 and 238, which is 72. Okay, and at this point, it all starts falling into place. So I guess, well, we could do the same thing with the graduate degrees, right? Oh, rats, I did it again. Oh, I am almost inclined to just edit the video and start over, but you know what? I want you to understand that if you mess up in a problem, that is not the end of the world. Wait a minute, no, that was right. That was right. Yeah, 2 and 3 is the undergraduate degrees. 2, 3, and 4 add up to 310. So yeah, you know what made me second guess myself is I based this off the undergraduate degrees, and then I'm writing something in the graduate region. Okay, so graduate degrees, that's regions 3 and 4. They add up to 184. 2, 3, and 4 add up to 310. So that'll give us region 2 will be 310 minus 184, which is 126. All right, and then I think there are 2 different ways we could get region 3. Maybe we'll do both of them just as a check. So whatever number I write in region 3, that number plus 126 needs to add up to 238. And also that number plus 72 has to add up to 184. So if I take that last thing, 184 minus 72, going to give me 112. And as a check, if I add 112 and 126, I get 238. So that checks out. All right. So their question was, we can switch over to the tablet to the presentation for this part, rather than trying to cram it in here. Okay, so this looks like how we did getting the basic regions. Okay, the number of presidents with exactly 1 business degree corresponds to the shaded region. It's shaded in both green and pink. Adding the number of people in the 2 shaded regions gives 126 plus 72, which is 198. All right, and that brings us to the end of this section. Thank you for bearing with me. The universal set can be divided up into a number of non-overlapping regions called basic regions. These regions can be used to determine the number of elements in a variety of subsets of the universal set. And that's going to do it for section 5.3. We'll see you next time.